Look up. So we're going to start a new chapter now. That was the last worksheet on arithmetic and geometric, the practical problems. I think everybody found the chapter okay. Probably the most difficult part might have been the geometric worksheet. Okay? But in the exam, they prefer to do the practical problems when you have, so like the practical worksheet is more common than the worksheet before it, okay? So the practical one, it's important that you try them all for homework. I gave you 4 to do. The other 2 you can try, but I think you might have trouble with it, okay? So there's at least 4 you can do. This new chapter is all about exponential and logs, or in other words, powers and logs. We've kind of done a little bit with powers so far, but not too much. And there's actually, I think, 5 or 6 rules when it comes to powers. Some we've already seen, but some we've not. So I'll give you the rules when it comes to powers. The first one, I think we all know. When you multiply 2 numbers, like this, the power is you add. So you get x power n plus m. But I think we all know this one. Number 2 is when you divide. What happens here? You minus the powers. Good, okay. Now we're starting to do ones which you might not know, or, well, haven't seen. When you have something with a power, and then another power, multiply the powers. Next one now. Nth root of x can be written as a power. Does anyone know what power? No?
1 over n.
Yeah, power 1 over n. So for example, cube root is the same as x power 1 over 3. Okay? And then the last rule, but it's not really a rule, more just an identity. X power 0, what does that equal? Does anyone know? 1. And then x power 1, what does that equal? X. Sorry. And then the other thing to know is that 0 power x, what does that equal? 0. Now, I should also say that here we don't use 0. So the last thing to say in rule 5 is that this number here, 0 power 0, is not a number. And you can see why, okay? If I have something to the power of 0, what should the answer be? 1. And if I have 0 to the power of something, what should the answer be? 0. So if I look here, this is something to the power of 0. So what should it be? Maybe 1. But then if I look at the bottom, this is 0 to the power of something, like this situation here, and the answer should be 0. So in fact, it's undefined.
0 over 0.
Like 0 over 0. There's no number for it. So if you get 0 power 0, something has gone wrong. It's not defined. So there are the 5 rules when it comes to powers, or another word for powers is indices, or index maybe. So these are the rules of powers. Make sure you write these down now. So there's 5 rules, yeah?
Sure.
One sec.
What do you write when powers sort of the basic are not the same?
Later. So for today, we won't be looking at that. But yeah, you need it to be the same. So can you write those 5 rules down, please? Go up a bit, yeah. Let's make it a rule. If you go to different maths books, they might list 3 rules, they might list 4, they might list 5, they might list 6. It's not like it's set in stone, okay? I'll just tell you that really the most important ones are the first 4. And in fact, some maths books would only list these 4 as the rules, okay? Some maths books would list 5 like this, and then some might even list 6. So the extra one that you might see if you didn't know it is if you have a negative power. Does anyone know what you do there? Yeah, it just gets flipped. So it's 1 over xn. So basically, depending on which book you look at, there'll be between 4 and 6 rules. So I can't think of anything else they might say. So there's all 6 of them.
It's like 0 minus n, so x.
Yeah, so
0 is 1.
it's really the same as rule number 2 and rule number 5 together. Yeah, it's like rule 2 and rule 5 was put together. Okay, so there's the 6 rules. But I think it seems like everybody knew all of these rules already. So probably what's more important now is actually using them for problems. So I'll do 1z, 2z, 3j. I'll do the last one in each part. So our first one now. 1z. x6 divide x4. Which rule do I need here? Use rule number 2, and this would be x squared, x2. 6 minus 4. Nothing else than that, that's it. Okay? So question 1 is all about just practicing the rules. Simple, straightforward. Now, number 2, you can see now it's getting more difficult. So 2z. Square root 4, square root 16, 32, fifth root 32. Looks difficult, but it's not too bad because it'll very quickly simplify. Many different ways to do it. What do you think I should do first here?
First one.
What are we thinking? I could do the root 16, couldn't I? Or I could cancel here by 4. But let's do the root 16 first. So what's root 16? 4. And 4 times 4? 16. So this becomes root 16 over 32, fifth root 32. Because, I'll put it in red here, this thing here was equal to 4. Alright, what do you think I should do next?
32 to the power of 1 over 5.
I think I'll do this bit in the front next for me. So 16 goes into 16 once, and 16 goes into 32 how many times? Twice, yeah. Okay. Now, let's take care of this fifth root business next. So what's the fifth root? What is that as a power?
1 over 5.
Yeah, so this is 1 over 2, and then here is 32 power 1 over 5, like that. Yeah?
Can't take the fifth root straight away. Do it.
Yeah, if you had your calculator, but wait. In the exam, they would sometimes say things like, simplify this, showing the steps. I'm sorry. So, 32, I should write that as a power. What is 32 as a power? 2 power 5, isn't it? So this is 1 over 2, and then 32 is 2 power 5, and then power 1 over 5. Okay, now I have two powers, so I multiply them. 5 times 1 over 5? 1, and 2 power 1? 2, okay. So it's 1 over 2 times 2. Yes. Square root of 4? Half. So that's the answer then. It's 1 over 2. Yeah. You probably need me to scroll up, right? No? So how far? There? Please write this down, because they might ask you in the exam, simplify that showing the steps. So of course you could have put that into your calculator and you would have gotten 1 over 2, but you won't get any marks in the exam if you do that.
What they do is
2 power 1 is 2, 2 power 2 is 4, 2, 4, 8, 16, 32. It's just one of these things that you see it and you know it. Like for example, what's 9? It's 3 squared. What's 81? 9 squared. 125? 5 cubed. It's just something you recognize, So 32 is 2 power 5. 64? Well, you've got 2 power 6, or you could also say 8 squared, and so on. 2 power 2 power 6 is 64.
2 power 10 is 1024.
Yes, okay, and it continues. Sorry, I was thinking of something else there. I got distracted. Avenue was very distracting. Right, okay. Do you have that taken down? Number 3 now, so. Square root x5, square root x minus 5, all over x minus 5, fifth root x5. This is 3j. What's wrong? Is this okay? 3j? Yes? Oh. 3j. Now everything is all right with the word. Okay, so what do you think I should do here first? Well, these are dividing, so what do I do to the powers? Subtract, so 5 minus 5? 10, so this is x power 10. And this is square root, so what square root as a power?
Minus 5 over 2.
Isn't it?
Oh, you're right, sorry. This is me not being able to read. This 5 is tucked in here as a fifth root. Alright. Well, I'll look at the fifth root. So, what power is fifth root?
Minus 5 over 5.
Wait, what power is fifth root?
1 over 5.
1 over 5. So minus 5 times 1 over 5? Very good. And then here, this is fifth root. So 5 times 1 over 5? 1, okay. And then here is x minus 5. Okay. So on the top, I add the powers. So what do I get? 1 minus 1? 0. And then here I add the powers, what do I get? Minus 4, good. And then here I subtract the powers, what do I get?
1 over x.
X power 4. And then square root is what power?
2.
A half. So yeah, 4 times a half? 2. So the answer is x squared then.
So why did it become positive 4 instead of negative 4?
Here?
Yeah.
Well, it's 0 minus 4. So it's positive 4 then. Is that okay?
Yeah.
Yep. Scroll up a bit. Okay, go down a little bit. Number 1 is too easy for the exam, but I've seen number 2 and number 3 in the exam. Okay, so now number 4. If you remember in the computer class, I told you of how to some important constants. So one constant we talked about was pi. You all know pi, don't you? There's another constant in maths called e.
2.71. 8.
Yes? All you need to know is e is a constant like pi, and it has a certain value. So really you just need 2.718 will probably do. But anyways, you don't need to remember it because it's actually on your calculator. So for example, if you want to calculate e squared, you don't need to type in 2.718 squared. I believe it's on your calculator. There's an e button. So what's e squared now?
7.389.
Yeah? Yes? What were you checking?
The number.
I didn't make it up. Right. Okay. So there's absolutely nothing for me to do with you on number 4. Number 4 is just take out the calculator and type it in. So actually what I've done there is 4j, funny enough. 4j is e power 1, which will be 2.718. Because e power 1 is just e. Number 5, I'll leave and talk about number 5 in the next class. It's the graph of it. No, actually, you know what? No. I'll show you the graph of it now, but I'll show you in the next class how to draw it. So, I'll get the program out for it. So, I'm going to do 5j graph now. But I'll explain in the next class how to draw the graph on paper. You don't need to do it for today. So, okay, where's my program gone? All right. So the last one, y equals 4e, control e, power 4x. So there you go there. And the graph of it, reset. Let me zoom in a bit. Actually, let me zoom out a bit. There we go. These e-graphs basically are very graphs that increase very quickly. Okay. In fact, the word exponential is often used in English to mean quick growth. Okay. So in English, if you said something was growing exponentially, you basically mean it's growing very quick. And the reason for that is because when you look at this graph of this e function, which is called exponential, you see how quick it grows. So like if I zoom out here, you see, here's the number 5, and before it even gets to the number 5, it's already up at like 400. So the graph comes along flat and then just shoots up. But we'll talk more about the graph the next time. I just wanted to show you on the program here what it looks like. So you just picture these exponentials as shooting up quick. Huh? Very, very quick and very big, yeah. No. Take the pencil case back out. You're not finished. What I'd like you to do for homework, and you can start it now, is question 1 to 4, the first 4. So So I'll say that again. Question 1 to 4, the first 4. And you can try these for 5 minutes, it won't kill you.